Hi, Chris Kuzmal here. So we've established in a relational logic exactly what a truth assignment is and how that corresponds to the Urban base. Let's use an example that is hopefully a little more intuitive. And in this case, we're going to say that our truth assignments correspond to the picture you see here. The official listing says that Dasha is blue, ball 2 is blue, Dasha kicks ball 1, Dasha kicks herself. Poor kitty, that's why she's unhappy. Ball 2 is cute, and note that although you might feel Dasha and Leopard are cute as well, and possibly even ball 1 is cute, we're going to be saying that only ball 2 is cute. Every other relational sentence in the Urban base, remember there were 20 of these relational sentences that exist in the Urban base, only these 1, 2, 3, 4, 5 relations are true, okay? Every other one is false. And now what we're going to do is we're going to look at our example logical sentences and evaluate them for this world. So in example 1, we have the logical sentence that says, for all x, blue of x implies cute of Dasha. That's how you would have read it pretty darn officially. It's an important detail here that I've highlighted, and that is that the scope of the variable x only extends in the yellow region because there's no parenthesization that extends across the implication operator. And so that means that when we expand or ground this sentence, then blue of x becomes blue of Dasha and blue of Leopard and blue of ball 1 and blue of ball 2. And that all is on the left-hand side of this implication operator. And then we put on the right-hand side that Dasha is cute. When we evaluate this, we look at our truth assignment, then recall that the antecedent, note the antecedent is false. The reason that's false is because not everything is blue. So one of these guys is not blue, and therefore the sentence is true, because no matter what the right-hand side is, and Dasha, incidentally, is not cute in our world, this sentence is nevertheless true. Let's look at example number 2. In example number 2, the structure of the logical sentence is almost identical to example 1, except we've extended the scope by putting parentheses around the entire implication. So this changes the structure of the grounding of that sentence so that we now have a disjunction of implications rather than a disjunction. Here we have a disjunction that is the antecedent to an implication. Here we have a set of disjunctions which are each they're each conjuncts. And so now all of them have to be true in order for our overall logical sentence to be true. And we can see in the very first clause, Dasha is blue. And that's why this is colored green, green meaning true, not blue, although Dasha being blue, maybe I should have made it blue. I don't know what to tell you. And then the right-hand side of the implication says that Dasha is cute, but Dasha isn't. And in the one case, and the implications evaluate to false is when the left-hand side is true and the right-hand side is false. So that means that this first clause, a clause being an element of a conjunction, this is false, and that means that we don't even have to evaluate the rest of the logical sentence to know that in the example 2 sentence in our world for this truth assignment evaluates to false. Okay. In example 3, now we change the right-hand side of the implication operator to have a binary relation between Dasha and x. The scope of x is still across the entire sentence. So we again build a set of implications, each of which is conjoined with the others, and that means each one of these implications has to be true. And once again, although the first 2 will evaluate to true, the third one evaluates to false because Dasha does not kick ball 1, but ball 1 is blue, and that's enough to make it so that the entire sentence evaluates to false. Okay. So broadly speaking, in order to evaluate a universally quantified sentence, we check that all the instances of the scope are true. In other words, that the whole thing is one big conjunction. We just had a conjunction here in example 3, and a conjunction here in example 2, and a kind of a conjunction that was part of the sentence in example 1. So next up, we're going to consider examples that involve an existentially quantified sentence in which we check to see at least one instance of the scope is true, and therefore in effect treating it as a disjunction of those instances.